let's do a quick recap of the idea of functions and their graphs. So a function is simply some kind of a rule that maps a set of inputs to some other set of outputs. So for example, we're familiar with little spider diagrams. You might have encountered this when you were young. So you'd have a whole lot of inputs coming into this machine and the corresponding output. So for example, the question would be, if my input is 1, what is the output going to be? So you're adding 2, which gives you 3 times 3 gives you 9. Or if your input is 5, then your output is 21. If your input is negative 2, then your output is 0. If your input is a third, then I think you end up with 8. Yeah, someone can check me there. So this is, no, you don't end up with 8. You end up with 7. Sorry, pedantic. Anyway, so we're well acquainted with spider diagrams, function machines. These are things that we know how to work with, and this is essentially a function. This is your inputs and these are your outputs. Obviously, this is quite a cumbersome way of representing a function because this limits your representation. You can only put down so many numbers, and so a useful way of representing a function is with what we call function notation and graphs. So function notation, for instance, would take this function. It would represent input as x, call this function some name. So we could call this function f, but this is a completely arbitrary letter. It could easily be g or h or p, whatever makes you happy. And typically the output will be called y, or it might be called f of x. And let's look at how we could then represent the function using this notation. So you could say that this function takes my input, adds 2, and multiplies the result by 3. So when my input was 1, I added 2 and I times by 3 and I got 9. When my input was 5, I added 2 to 5, got 7, times that by 3, got 21. So this is how you could represent a function. So you give the function some name. Again, it could be f, it could be g, it could be p. And then this guy in the brackets represents your input variable. So in this case, we're calling our input variable x, and very commonly we call our input variable x, but again, it's not limited to x. So what we're saying on this side of the statement is, this is what the function f does to an input x. You take that input, you add 2, and then you multiply the result by 3. So that gives you your output. So f of x essentially represents your output, the output of a particular function f. Or another way that it could be written is, it could be written as y is equal to 3 times x plus 2. So y represents output, and this is how we're processing our input to get that output. So that is what a function is, in short, some kind of a rule that transforms input into output. And then a useful way of representing a function is through a graph. So if we just run with this example, what we do to build a visual representation of it by way of a graph is we transfer it onto a Cartesian plane, which is basically 2 number lines crossing each other. This number line we call the x-axis, that number line we call the y-axis, and this is basically a system of coordinates. So, the number lines can be numbered. And so through this system, you can label any point in the space. So for example, this point over here would be labeled using 2 numbers. The first is what we call the x-coordinate. So how far have I moved from the middle place, left or right? So I've moved 1 unit to the right and I've moved 1 unit up, and this is what we call our y-coordinate. The vertical component is called the y-coordinate. Or for example, this point over here, the x-coordinate would be -3 and the y-coordinate would be 2.